In this session, we'll learn how to use the toolkit to compare both the variances and the means of two or more samples using ANOVA. We've been using a case study based on the impurity content of a product that can vary from batch to batch, or between day shift and night shift, or depending on which machine was used. We saw in the video on stratifying data that there seems to be a difference between the three machines. Let's have a look at that again. I'll click the button for stratified plots and I'll pick impurity content as the thing that we're plotting, and I'm going to stratify it with machine. It's hard to see what's going on in the time series plot, but the box plots do seem to suggest that machine 220 might be producing more impurities than the others on average. As there are more than two groups, we can't use t-tests here, but ANOVA will work well. The first step is to compare the three groups to see if there's a difference in their variances. If there is a difference, that will be a useful finding in its own right. So we're scrolling across to the right and we can see this test. The graph shows the confidence intervals for the standard deviations of these three groups, and we have two p-values. Bartlett's test is relevant if the data is normally distributed, while Levine's test is relevant if it's not. In the interest of time, I'm not going to perform that check for normality here, but if you watch the video on stacking and unstacking data, you'll see how to do it. Anyway, whichever test we use, the p-value is over 0.05, so there's no evidence that the variances are different. Then we can go over to the one-way ANOVA. And this is what tells us whether there's a difference in the means of the three groups. Speaking strictly, you should only perform this test if the p-value for equal variances are above 0.05, which is the reason that we've arranged the tests in this order, so that as you scroll across, you're doing things in a logical sequence. To be honest, in practice, it doesn't cause a big problem with one-way ANOVA if the variances are different, so long as the sample sizes are roughly similar. Anyway, we don't have an issue here. So, we can see the confidence interval for the means of the three groups, and immediately we can see the p-value is 0, so we have proved there's a difference in the means of the impurities coming from the three machines, and that should be investigated to find the cause and hopefully get an overall reduction as a result. All the information about the sample sizes and confidence intervals is provided in this data section. So that's how ANOVA works with the toolkit. We've now had a few tasks where you'll face some challenges if your data is unstacked when you want it to be stacked, or vice versa. So in the next video, I'll explain how to make that change.